So I'm going to try and give a talk about this model that was developed a number of years ago, but we've since been trying to move it onto DAFNI to make it more accessible and widely applicable. And the starting point for this was my earlier work looking at flood risk assessment. So we're looking at the probability of how, when rivers burst their banks, storm surges, flood cities, and then the damages that come from that. And that is often how we calculate risk. And that's often based on a sort of a static number and a series of static assumptions. And yet, if we look around the world at flood events, the same communities can get hit and have very different experiences of what damages or loss of life can be like. And that's a result of, I suppose, the different resilience, capacities and responses. Some are able to get back on their feet much more quickly, and all of those individual, community, institutional kind of activities and actions affect what actually happens and the scale of that impact. And we wanted to try and explore some of that and think about how different activities and choices during a flood event might influence that outcome. This is Tywyn and Rhyl in North Wales, where some of the early case study work of this was done. And what you'd see is the water comes surging in after several of the flood defences are breached. And then little blobs, or what look like little blobs, start moving around, and you start to see them rushing towards the Newcastle University logo, which is where we'd located a safe haven, or at least imagined there might be one. And what we are able to do with this tool is explore a wide range of different scenarios, looking at how different sort of magnitudes of extreme events or different choices about our response and actions taken as individuals or at the sort of macro scale influence the sort of outcomes of an event. Underneath this is a whole host of different types of data, spatial data describing how the network, the road network is configured and connected, locations of buildings, information on travel patterns from local travel and national travel surveys, and then assumptions derived from that around how people move around town, at least in a normal kind of day-to-day routine. And then further assumptions around how people respond during an extreme event. And so each of the sort of individual people, agents within this can receive signals directly from each other, from some kind of warning system, or from seeing some water in their backyard and take a decision accordingly. And this allows us to identify where people are likely to be exposed under different scenarios to extreme and dangerous depths and velocities of floodwater. And so in 1990, this town flooded. This was why I ended up sort of working here a number of years ago in that location, which is marked by the big blue arrow. And then we can pull out some indicators of where people might end up getting exposed. I hesitate to use the word drown, although I often slip into that. It's not really, it's where they're exposed to water that is dangerously deep or dangerously fast. And we can look at one event, or we can look at lots of events. And I think one of the things that was especially interesting for me when I did this work first was identifying that if we were to sort of pick out the priorities for investment in our flood infrastructure and base that purely on property and economic value, and this was the sort of a national risk assessment a number of years ago, we'd pick those sort of red arrow defences where you can see there. But if we were to focus it on vulnerability to people, we end up with a different prioritisation of where we'd spend our money. And that's by pulling in a whole load of simulations of different breach locations, different scales of events, and so on. We can also look at how different choices about evacuation influence outcomes. One of the features of Towyn is it's not just low-lying, kind of reclaimed floodplain, but it's also full of bungalows and caravans. These are not places that you can rush upstairs to get out of floodwater. And so actually there's a smaller number of refuges than might normally be available in a typical town. So we looked at a wide range of different options, and you can test how well for a particular sort of flood each evacuation shelter sort of performs in terms of enabling you to get people to safety. And unsurprisingly, if you've got an evacuation shelter right behind the where your flood defence breach is, it's not a very good place to have it. Which is why a sort of a multiplicity of sites is often the right way forward. But this is a sort of a demonstration of what can be achieved. We're also able to identify where choke points occur. We've seen, we don't have to think very hard to imagine if everyone's trying to get out of a city or a town, how quickly those roads get congested. In the States, they're much more used to these sort of large-scale evacuations in hurricane-prone cities and make, or if you like, introduce that contraflow to get more people out faster. We're not so good at this in the UK yet. But by being able to identify where some of those pinch points might be under different scenarios, we can again start to better inform how to evacuate and plan those evacuation strategies during extreme weather. So what have we been doing in DAFNI? Well, as I said at the start, the hard work here has really been done by Janetta and her colleague Robin. And I think much as we heard from the DRES project, a really nice breakdown of some of the challenges of, if you like, taking out and extracting some of the embedded assumptions that we'd put in our original code and trying to separate that out into workflows, standardizing the data formats and inputs, but also then providing a sort of an example data set and case study. And so there's been a lot of work in trying to unpack that original code, recode it in Java, standardize the sort of the inputs and so on to try and make this more readily accessible and available. I think we're nearly there to be releasing this publicly soon after a bit more user testing, but we've made some really great progress here as well. And I said at the start that Michael and Olivia had been busy looking at alternative kind of directions and ways forward for this, and Michael's been doing some nice work looking at different types of hazards. In this case, it's a bomb threat in Newcastle, and working with the local resilience forum there. And Olivia's been looking at how this sort of tool, which does need quite a lot of data, could be adapted and transferred to places where data is maybe not so rich and easily accessible. And this is an application in Nairobi in Kenya with quite different context, quite different sorts of challenges. But we're still able, albeit with probably even more caveats than applying this in Wales, get out some useful insights into vulnerable locations and areas where congestion is more likely to occur during extreme weather and evacuations. And so on that, I'll leave it there. Thank you very much.